Hi, my name is Teteje Kepsi Richard. Welcome to my YouTube channel. The saying goes that no one is perfect. That's why pencils have erasers. This means that in our day-to-day measurements and calculations, we may make errors. That leads us to today's discussion, measurements and error. Before the video will end, I will take you through some terms that will make us understand measurement and error. Then we'll look at some problems covering errors. This will be a very interesting engagement, so please be my guest. So let's look at some terms that will play a very significant role in our understanding of measurement and errors. The first one is measured value. Measured value is the amount of or the length of a physical quantity recorded by someone. It may also be called approximated value. So if we measure a line, let's say AB, and when we measure this line, we get 6 centimeters. Then our measured value is 6 centimeters. Actual value is the exact. Actual value is the exact or the true amount of or the length of a physical quantity. So let's say we have a line again, AB, okay, and the true value of this line is 6 centimeters. However, when we measure, we have 5.9 centimeters. Then the 6 centimeters become the actual value, and the 5.9 centimeters become the measured value. I hope you get that. The next one is accuracy. Accuracy refers to how close a measured value agree with the actual value. So how close a measured value agree with the actual value, that refers to your accuracy. So let's say when you measure a line 6 centimeters and the exact length of the line is 6 centimeters, then you say you are very accurate. However, if there is differences, then we say that there is error. So we say error occurs when the measured value differs from the actual value. So when our measured value different from our actual value, then we say there is an error. There are 3 forms of such errors. These are absolute error, relational error, and percentage error. And they have direct relationships. So our next thing is that we'll look at what each of them means and their relationship. Then we'll take some problems and try solving them. So the absolute error is the absolute difference between the actual value and the measured value. So as I explained earlier on, if we have a line and the length of this line is 6 centimeters, but we measured and we have 5.9 centimeters, then the difference between the 5.9 and the 6 centimeters becomes the absolute error. Remember, because it's absolute value, when we get negative self, it will be positive. Then the relational error is the ratio of the absolute error to the actual value. So we say relational error is absolute error over actual value. Remember, absolute error is the absolute value of actual value minus the measured value. So we can also say that the relational error is equal to the actual value minus the measured value all over actual value is the same thing. Since absolute error is this, we can replace this by that. Now let's go to the next one, which is percentage error. Percentage error is the ratio of absolute error to the actual value expressed as a percentage. So when we express the ratio of the absolute error to the actual value as a percentage, then that becomes the percentage error. So we say percentage error is absolute error over actual value times 100%. Or we can also say, remember, absolute error is the absolute difference of the actual value and the measured value over the actual value. So we can say over the actual value times 100%. Also remember, the absolute error over actual value is a relational error. So we can also say percentage error is relational error times 100%. I hope you get that. So our next step is that we take some problems and see how we calculate all these errors. So let's look at a very simple question. It said the meteorological agency forecast 2 millimeters of rain, but actually recorded 25 millimeters of rain. Calculate I, the absolute error, I, the relational error, then I, the percentage error. So the actual rain, that fell, so the actual value is 25 millimeters of rain. But they forecasted, so we can say projected value, which is the same as measured. So projected value is equal to 20 millimeters. So we are asked to calculate the absolute error. Remember, we said that absolute error is equal to the absolute value of actual value minus the measured. In this case, actual value minus projected value. So we go, our actual value is 25 millimeters minus the projected value, which is 20 millimeters. So when we subtract that, we have the square root, the absolute value of 5 millimeters, which is the same as 5 millimeters. So we can say that the absolute error is 5 millimeters of rain. Now we'll go to the second one, which is relational error. So remember, relational error is equal to the absolute error over the actual. You can say absolute error over actual value. Or it can be the absolute value of actual value minus the projected value, the same thing. So our absolute error is 5 millimeters over our actual value, which is 25 millimeters. So over 25 millimeters. So this will be 1 over 5, then equal to 0.2. So the relational error is 0.2. Now we find the percentage error. So our percentage error, remember, we say it's equal to relational error times 100%, or the absolute error over actual value times 100%, or the absolute value of actual value minus the projected value, the same thing. So we can have our relational error times 100%. And our relational error is 0.2 times 100%. So 0.2 times 100%, that will be 20%. So the meteorological agency made a 20% error in forecasting the 20 millimeters of rain. So let's look at our second question. A student calculated the area of a triangle of height 16 centimeters and base 10 centimeters and had 100 centimeters square. If the student made an error, calculate his or her A, the relational error, then I, relational error, then I, percentage error. So remember I said that anytime the measured value is different from the actual value, then there is an error. So if the student really made that error, there will be a difference. However, if they are the same, then there is no error. Then we say the student is accurate. So let's see. Remember, the area of a triangle is equal to half base times the height. The base in this case is 10 centimeters and the height is 16 centimeters. So you can say the area will be equal to half times 10 centimeters times 16 centimeters. So this will be half times 10 will be 5 centimeters times 16, and that will be 80 centimeters square. So we have read that is the actual value of the area of the triangle. So we say actual value is equal to 80 centimeter square. What did the student have? The student's measured value or calculated value. The student measured value was 100 centimeter square. So there is difference. As far as there is difference, then there is an error. So we can calculate that error. The first one, relational error. So remember the relational error is equal to the absolute value of the actual value minus the measured value all over the actual value. So what do we have there? We can say the absolute value of our actual value is 80. So 80 centimeters square minus the measured value is 100 centimeters square over actual value 80 centimeters square. So what do we have? 80 minus 100, that will be negative 20 centimeters square over 80 centimeters square. The absolute value of negative 20 will be 20. So we'll have 20 centimeters square over 80 centimeters square. And this will be 1 over 4, which is 0.25. So we can say the student made a relational error of 0.25 in computing the area of the triangle. The next one is the percentage error. So the percentage error, remember, is equal to the absolute value of actual value minus the measured value all over the actual value times 100%. And remember, the absolute value over the actual value minus the measured value over the actual value is the relational error. And when we computed that, we have 0.25. So you can say that all of this is 0.25 times 100%. And that will be equal to 25%. So we can say the student made 25% error in measuring or computing the area of the triangle. So let's look at our next question. They say Miss Pa was asked to evaluate the integral spanning from 1 to 4 of 2x plus 4 all over x cubed dx correct to one decimal place and had 3.3. So when she computed it, she had 3.3. Did she make an error? If yes, compute her absolute error. Relational error, then I, the percentage error. Remember I told you that anytime the measured value is different from the actual value, then there is an error. So let's compute this ourselves to see if Miss Pa made an error. So the integral spanning from 1 to 4 of 2x plus 4 over x cubed dx. This can be rewritten as the integral spanning from 1 to 4 of 2x over x cubed plus 4 over x cubed dx, which we can rewrite again as integral spanning from 1 to 4 of 2 of x 2 over x square, that's this x will divide one of this, plus 4 over x cubed dx. Using indices, we can rewrite that as integral spanning from 1 to 4 of 2s exponent negative 2 plus 4s exponent negative 3 dx. Now we compute this. We integrate this 10 by 10. So we add 1 and divide the function by that result. So we have 2s exponent negative 2 plus 1 over negative 2 plus 1, then plus 4s exponent negative 3 plus 1 over negative 3 plus 1, spanning from 1 to 4. So, we'll compute this further. What do we have? So, negative 2 plus 1 will be negative 1. So, we have 2s exponent negative 1 over negative 1 plus 4s exponent negative 2 over negative 2, spanning from 1 to 4. So, what do we have? When we solve that further, we'll have negative 2 over, I'll bring the s down, so x, then minus negative 2 divided by 4 divided by negative 2 will be negative 2, so negative 2 over x squared, spanning from 1 to 4. Remember, this is limit integration. We substitute the 4 in place of the variable, minus substituting 1 in place of the variable. So when we substitute our 4, we'll get negative 2 over 4 minus 2 over 4 squared, then minus negative 2 over 1 minus 2 over 1 squared. So we'll compute this further. We'll get negative 2 over 4 minus 2 over 4 squared is 16, minus negative 2 divided by 1 is negative 2. 1 squared is still 1, divided by that will be negative 2 again. So we'll find the LCM here. The LCM here will be 16. 16 divided by 4 is 4. 4 times this, negative 2 will be negative 8. 16 divided by 60 is 1 times that will be negative 2. Minus negative 2 minus 2 will be negative 4. So we'll have negative 10 over 16 plus 4 over 1. So this negative 10 divided over 6 can be negative 5 over 8. That's dividing both the numerator and the denominator by 2 over 4 over 1. The LCM is 8. 8 divided by 8 is 1 times negative 5 will still be negative 5. Then 8 divided by 1 is 8 times 4, that will be 32. Negative 5 plus 32 will be 27 out of 8. When we change this to decimal, we get 3.275. So when we correct this to one decimal place, we get 3.3. 27 divided by 8 is 3.375, and now to one decimal place with 3.4. So we can say that the actual value of this integral, the actual value is equal to 3.4 to one decimal place, and the student measured or computed value is equal to 3.3. So since there is differences between them, then the student made an error. So I say, did she make an error? So the answer is yes, she made an error. So if yes, we compute her absolute error. Remember, the absolute error will be equal to the absolute value of actual value minus the measured value. So the absolute value of what's our actual value? 3.4, and the measured is 3.3, or the computed value. On straight difference, we get the absolute value of 0.1, which is equal to 0.1. So the student's or Miss Spar's absolute error is 0.1. Then the second one, which is her relational error. Remember, relational error is equal to absolute error over actual value. So the absolute error is 0.1 over actual value 3.4. When we compute that, we get 1 out of 34. So when we change 1 over the 34 into decimal, we get 0.0294. So now we know the relational error. We can compute the percentage error. So we calculate her percentage error. So percentage error, remember, is equal to the absolute value of actual value minus the measured value all over the actual value times 100%. Remember, when we computed the absolute value of actual value minus the measured value over the actual value, which is the relational error, we have 0.0294 times 100%. So 0.0294 times 100% will be 2.94%, correct to 2 decimal places. So we solve our last question for the day. But before we do that, please do these 4 things for me. Like my video, comment, share, and subscribe if you are here too. So the last question says, a student made a percentage error of 5% when approximating 2.64923 correct to 2 decimal places. Find his or her approximated value. So when we approximate this to 2 decimal places, you can say that the actual value of that to 2 decimal places will be equal to 2.65. However, the student get a certain value, so we don't know. So we say we should let the student's approximated value. The student's approximated value be equal to x. Remember, the percentage error is equal to the absolute value of actual value minus approximated value all over actual value over the actual value times 100%. So how do we do this? So remember, the percentage error is 5%. So we can say 5 equal to the actual value is 2.65 minus the student's approximated value, which we don't know, so x, over the actual value, which is 2.65 times 100%. So we can cross multiply this. You get 5 times 2.65 will be equal to 100 times absolute value of 2.65 minus x. So I'll multiply 5 by that. We'll get 13.25 and to be equal to 100 absolute value of 2.65 minus x. So we can divide both sides by 100. When we divide both sides by 100, we get 0.1325 equal to absolute value of 2.65 minus x. Remember, absolute value of any number will be plus or minus that number. So you can say absolute value of 2.65 minus x will be, so 2.65 minus x, absolute value of that can be equal to plus or minus 0.1325, plus or minus that. So I'll make our s the subject. Our s will be equal to 2.65 plus or minus 0.1325. So we take the positive aspect. We get s will be equal to 2.65 plus 0.1325, or s can be equal to 2.65 minus 0.1325. So I'll take the positive aspect. Our s will be equal to 2.7825. Correct to 2 decimal place will be 2.78. Then the negative aspect will get 2.5175. Correct to 2 decimal place will be 2.52. So we can say that the student actually approximated 2.64923 as 2.78 or 2.52. So please, we'll end it here today. Remember to subscribe to my YouTube channel and check out my videos on how the error in measuring one physical quantity will affect the other. For instance, when we make error in measuring the radius of a sphere, how it will affect the volume or the total surface area of the sphere. Until then, my name is Richard.